Hello, Earth and Space Science. So this video will be quicker than what I lectured on before. It will describe how to calculate the distance to a Cepheid variable star. So we'll do delta Cephei, which was our first example in class, and I will go through that process. So the process starts with a light curve. So on a light curve, are two important pieces of information about any Cepheid variable star. You have the period of the Cepheid variable star from its brightest point to its brightest point, or its dimmest point to its dimmest point. In this case, a delta Cephei. Our period is equal to 5.4 days. Right? So notice time is in days. From here to here is 5.4 days. The other important piece of information is this apparent magnitude. So apparent magnitude is how bright something appears from Earth. So this is from a telescope with a photometer on it. And notice delta Cephei ranges from 4.3 to 3.6. 3.6 being actually brighter. Smaller numbers are brighter on this scale. What we're going to want for our calculation is actually the average. So what you have to do is you have to add those numbers, 3.6 plus 4.3, and divide by 2 to get an average apparent magnitude of 3.95. Henrietta's famous relationship was about the period. From the period, we can get an important value, which is called the absolute magnitude. So this is different than the apparent magnitude. The absolute magnitude is how bright something appears if everything was placed at 10 parsecs, or about 30 light years away from you. And we read this graph to get that value from it. So I find my period, which in this case is about 5.4. I follow up to the line of whether your star is a type 1 or type 2 Cepheid. Delta Cephei is a type 1. And then I follow over. And what I realize is that delta Cephei has an absolute magnitude of negative 2.8. And we'll write that value down. So I know the apparent magnitude, I know the period, and I know the absolute magnitude. That's enough to now perform my calculation. So I use this distance equation. For distance. And I'll go through that calculation. Let me switch to my document camera. All right, now you see the work I've placed down so far. I have the apparent magnitude little m 3.95, the period 5.4 days, and the absolute magnitude of negative 2.8. I'm going to plug those values into this equation. 3.95 minus a negative number plus 2.8 plus 5 divided by 5. So in my calculator, I go 3.95 plus 2.8 plus 5 equals, divided by 5, and I get 2.35. So 10 raised to the 2.35. Again, put that in my calculator to get a distance of 224 is the unit this number is in. That's not very useful. So we actually want to convert that to light years. We do that by multiplying by 3.26. So by 3.26, because the 1 parsec is 3.26 light years, to get 730 light years. If you go online, you'll find that the distance using a more precise method is 887 light years. And from that, we can calculate what's called our percent error, the difference between our calculated value and our true. For this one, you take your actual value, subtract your calculated value, always divided by the actual value, then times by 100. I'm going to go 887 minus 730 divided by 887 times by 100. And I get to a percent error of 17.7%. And that's all there is. Let me zoom out so you can see the whole paper. There you go. And that's how you calculate the distance to a star using the Cepheid variable method.